Let's start today's session. So last day I have done coordinate geometry part. I revised coordinate geometry, then just started straight line equation getting part. Then today we need to do applications on that. So one application is about point straight line relation, another application is about 2-point and straight line relation, and last one it is about two straight line relations. Then that's all about straight lines. Okay, very simple thing. Okay, let's start from the beginning today. Write down topic. Relations between point and a straight line. Relations between point and a straight line. Relations between point and a straight line. Let's start. So here there are small theorems. So you consider, let ax plus by plus c equal 0, abc real is a straight line, is a given straight line. And alpha comma beta, p alpha comma beta is a given point. So here first theorem is about this position. You consider here case 1, here straight line, ax plus by plus c equals 0, then point P on the line. P is on the line. Here case 1. Then case 2, point outside the line. Here ax plus by plus c equals 0. Here P alpha comma beta. P is outside the line. To the line. Okay, this is case 2. So this is very simple theory. So if this point on the line, when you substitute it, then the equation is satisfied by that point. Then a alpha plus b beta plus c becomes 0. This becomes 0. When the point on the line, that becomes 0. So if this one outside the line, that not equal to 0. Very simple theory. Then here a alpha plus b beta plus c not equal to 0. Likewise, you can check it. That is theorem number 1. Okay, put that theorem. Okay. Now first theorem we can modify. First theorem we can directly modify here. Then here d, when you substitute t value, minus a alpha plus b beta plus c over a square plus b square. So we have to put modulus now. Times a square plus b square root. Then we can remove this modulus from here and we can remove this minus sign, no? Because by modulus we remove its sign, no? Then here a alpha plus b beta plus c. Here we don't know sign here, then we have to put modulus there. Then a square plus b square times a square plus b square root. Then this one surely positive. Then a alpha plus b beta plus c over a square plus b square root. Here modulus. Here likewise we can modify. You can directly apply. Okay? Do up to that. Now see this example. You consider 3x plus 4y minus 5 equals 0 and 1, 2. So you take here a straight line u, 3x plus 4y minus 5 equals 0. We can denote like this, like u, l, likewise we can denote. Now let's see how the position like. You substitute here 1, 2 to the line. You substitute 1, 2 to the line. Then 3, 1, 4, 2 minus 5. No? Here the notation. You put square bracket and put that coordinate. That means we have substituted the point. Now simplify. Here 8, 3, 11, 6. No? That becomes 6. Now that not equal to 0. Then therefore 1, 2 lies outside to the line 3x plus 4y plus minus 5 equals 0. 5 equals 0. Okay. Now we have 3 theorems now. D equal perpendicular distance. So now say here 2x 3x plus 4y minus 5 0. Here 1, 2. Then we have base coordinates, say P here. We have mirror point, P dash here. We have perpendicular distance D. Then you directly apply. See the theorem. So you apply this one directly. A alpha plus B beta plus C modulus of A square plus B square root. Very simple theorem. That is, we have substituted here A alpha plus B beta plus C. No? Then here the line. Then for this part we have substituted the coordinate. And we had put modulus. No? We had put modulus. And further we have in denominator x coefficient square plus y coefficient square root. Okay, now apply it here. See, substitute 1, 2 to the line. 3 into 1, 4 into 2 minus 5 put modulus over 3 square plus 4 square root. Here 3, 8, 6, 6 or 5 units. Likewise, you can directly get. Then base coordinate, we say AT plus alpha, BT plus beta. No? Then A value mean x coefficient. 3t, alpha mean given x coordinate 1. B mean y coordinate. Beta mean given y coordinate 2. Here base coordinate. Then further we have to find t, no? Then t is given, later we will prove this one. Then t equal here minus a alpha plus b beta plus c over a square plus b square. You remember this formula and directly apply. Later we can prove it. Okay, let's see. Then find t. T mean minus, you put alpha beta mean 1, 2 to the line here. 3 into 1, 4 into 2 minus 5 over 3 square plus 4 square, now root here. Then minus 6 over 25. Here this is t value. Minus 6 over 25. 3 minus 6 over 25 plus 1. 4 minus t over 6 over 25 plus 2. Plus 2. Okay, here simplify and get the coordinate. Here 25, 18, 7 over 25, 50, 24, 26 over 25. No? That is base coordinate. Then mirror point P dash, we say 2at plus alpha, 2bt plus beta. 2at plus alpha, 2bt plus beta. Then 2, a value x coordinate 3, t value minus 6 over 25, b coordinate alpha 1, 2, b value 4, t value minus 6 over 25 plus beta mean 2. You simplify and get final answer. Here 6, 36, 25, 11 over 25 minus 8, 2 over 25. 2 over 25. Check that simplification. Okay, now that is very simple theory, okay. Here we call capital T as a parameter, that parameter represent here this length, not exactly length, that related to that length, okay. Then here parameter T, here parameter 2t, twice of the length, no? Then here T, here 2t, okay. Now, you see this? Here you take gradient m, take one point here, alpha comma beta given. Then I'm going to write some point here, p. Say x bar, y bar, we call parametric form. So, if point is given and a gradient is given, point and gradient given, then parametric form. Then gradient mean y difference over x difference. Y bar minus beta over x bar minus alpha equal gradient m. Y bar minus beta over x bar minus alpha m. Now separate y coordinates y bar minus beta over m equal x bar minus alpha over 1. You say here t. We call t is a parameter, a variable parameter. Then x bar minus alpha equal t, we say x bar equal alpha plus t. Then y bar minus beta equal mt. Then y bar equal mt plus alpha, mt plus beta. So when you consider these two, alpha given, m given, beta given, only t not given. No? Then we have expressed coordinate x and y by single variable t. Therefore, we say that variable as a parameter. Usually we say t is a parameter. Now you consider here the gradient tan alpha. Let's say tan alpha. Then take this point alpha comma beta. Here say tan theta. So now here point x bar y bar. Now further you write y bar minus alpha over x bar minus beta equal tan theta. Tan theta means sin theta over cos theta, no? Now you cross multiply and separate it. X bar minus beta over cos theta, y bar minus alpha over sin theta. You say t here, t here. Then x bar minus alpha, x bar minus something wrong, no? Y bar minus beta here, x bar minus alpha, x bar minus alpha, y bar minus beta. Then x bar minus alpha equal t cos theta. Then y bar minus beta equal t sin theta. T cos theta and t sin theta. So when you find here say AP length, x bar minus alpha square, y bar minus beta square root. That is AP length. AP length, x difference square plus y difference square root. Then x bar minus alpha, t cos theta. Here t sin theta. Then t square take outside, cos square plus sin squared. That is 1. Whole thing root. Then here modulus t, AP, modulus t. That means t represent AP length. T related to AP length. Therefore say t related to is related AP length. That is parameter. Okay, you better to put that note. We have to practice that very. Okay. Then you go to question number 55. Question number 55. So, previous theorem we have to apply directly. First, we have 4 sections to find perpendicular distance from the origin to the straight line 3x minus 2y plus 5. Okay, just do it soon. Try these questions. You can apply theorem directly. Just apply theorem directly. So later we can prove it. Do soon. Do alone. Question number 55, first part. Perpendicular distance from the origin. We have direct theorem now. 3 times 0 minus 2 times 0 minus 5 modulus over 3 square plus 2 square root. Here 5 divided by root 13 units. Second one, 1 comma 2. 12 times 1, 5 times 2. Here plus not given. You forget it and put modulus. 12 squared plus 5 square root. 22 over 13 units. Third, 2 into 1 minus 1 minus 3 modulus over 2 square plus 1 square root. Here 2, 3, 0. Here 2, 3, 0. Then that point on the line. Point on the line, no? 4. 3 plus 2 modulus over 1 squared plus 1 square root. Identify properly. So first we have to substitute that given point to the line one side and put modulus and divide by x coefficient square plus y coefficient square. 5 over root 2 units. 5. That's all, no? That is 55. Do alone. Then 56. 56. Find the perpendicular distance from the point 2 minus 3 to the line. 2 times 2 minus 3 modulus over 2 squared plus 1 square root. Here perpendicular distance 4 or root 5 units. And the coordinates of the foot of the perpendicular, that means base coordinate. Base coordinate we have theory at plus alpha, bt plus beta. Na? Then a value 2, alpha value 2, b value -1, beta value -3. Then you find t equal minus a alpha plus b beta plus c. 2 into 2 minus 3 over 2 squared plus 1 square, here t. 405 minus 405 you put here, minus 405 plus 2, 405 minus 3, 205, 1105. Here this is base coordinate. 56. Check your answers. Okay, then 57. If the perpendicular distance from 4, 1 to the straight line 3x minus 4y plus lambda, no? Then 3 times 4, 4 times 1 plus lambda modulus over 3 squared plus 4 square root is 4 units. 4. Then we have to find lambda. 12, 4, 8 plus lambda 20. Then we have two possibilities for lambda. 8 plus lambda equal plus or minus 20. Then lambda equal to 12. Lambda equal to minus 28. We have two possibilities, that is 57. Then 59. The coordinates of the verges of a triangle is somewhat long. Do up to this here. Okay, then 59, here we have process. See 59, here we have process. Here vertices are given, say A, B, C. So here coordinates 0, 0, 1, minus 1. 0, 0, 1, minus 1 and 3, 2. 3, 2. Now we have to find length of the altitudes. Length of the altitudes, na? So altitude mean, here we have to sketch perpendicular, na? This is one altitude. So we can find here this length. If we know this line, then with this coordinate given, then we can find that length, no? Say D1. Then write AB line, 2-point form, you write equation y minus 0 over x minus 0, 0 minus minus 1 over 0 minus 1. Then here minus y equal x, x plus y equals 0 is AB. AB. Now directly apply. We know that line now. Then say D1 equal, here this is line, take this point, 3 plus 2 modulus over, here coefficients 1 and 1, 1 square plus 1 square root. Then 5 over root 2 unit. This is one length. Similarly, you find AC line, 2-point form. Here y minus 0, x minus 0, y minus 2 over 2 minus 0 over 3 minus 0. 3 minus 0. So we know how to construct the equation of the line. No? Here this is 2-point form. Then 3y equal 2x, 2x minus 3y 0. Then you sketch perpendicular, say D2. Then D2, you take this point with this line, modulus 2 times 1, 3 times minus 1, modulus over 2 square plus 3 square root. 5 over root 13 units. Similar way, you find BC. Find BC. Y minus minus 1 over x minus 1. 2 minus minus 1 over 3 minus 1. Y plus 1 over x minus 1. Here 3 over 2. 2y plus 2, 3x minus 3. Okay, then 2y plus 2, 3x minus 3. Then here 3x minus 2y. 3x minus 2y minus 5 0. Minus 5 0. Then we know the line. You sketch perpendicular. Say that length D3. Then this point we call orthocenter. We call that one orthocenter, that is special one. Okay. Then write D3. Here the line, the coordinate 0 0. Then 3 times 0, 2 times 0 plus minus 5. Modulus over 3 square plus 2 square root. 5 over root 13 units. 5 over root 13 units. Okay, complete it. Now let's prove our theory. Let's prove our theory. You take a line ax plus by plus c equals 0 and take this point alpha comma beta. say A. Then here base coordinate B, let's say P here, mirror point P dash, double distance. Okay. Now ax plus by plus c, its gradient minus a divided by b now. When you subject y, then x coefficient will be gradient, no? Minus a over b. Then here this is perpendicular line. Then MP dash, MP dash, it is perpendicular, no? Then perpendicular one gradient we know takes reciprocal and reverse the sign, no? Then here b divided by a. Here a divided by b divided by a. Now you take here point here x bar y bar. I'll take here point A. Here a dash. Here say P. Here general point. General point. Then by these two you write gradient. Y bar minus beta over x bar minus alpha. Then y bar minus beta over b, x bar minus alpha over a. You take t here. Here this is general point now. Then you say t variable parameter. Here variable parameter. Variable parameter. Then by this you can find x bar minus alpha equal at, x bar equal at plus alpha. Then here y bar minus beta equal bt. Then y bar equal bt plus beta. Bt plus beta, no? Then here simple t corresponds to point P, no? T means a parameter. We call variable parameter. So variable parameter means by varying that t, we can get any point on this line. So simple t correspond to P. Now you consider, let capital T is the parameter related to point B. Point B. You consider capital T is the parameter related to point B. Okay. Now simple t, identify difference. Simple t, the variable parameter. Simple t, variable parameter. Capital T, parameter related to B. Then here, this is our point. Then here P point you can write A simple t plus alpha, B simple t plus beta. Therefore you say B point, you can replace only simple t by capital T. This is general one. Then say A capital T plus B, beta, alpha, B capital T plus beta. This is B. Then AB distance, here A coordinate, AT plus alpha minus alpha, x difference squared, BT plus beta minus beta, y difference square root, AB distance. Here one theorem. Here we get A square T square, B square T square root. Now T square common, A square plus B square, whole thing root, then we don't know T exactly, then we have to put modulus. A square plus B square root. This is another theorem, no? Two theorem proof. Now anyway, here parameter related to B is capital T, then parameter related to A dash will be 2t, no? Twice the distance. Here capital T, then this will be 2 capital T. Therefore parameter related to A dash is 2t, is 2 capital T. Okay, 2 capital T. Therefore, here you replace here simple t. Here you replace simple t by 2 capital T. 2 capital T. Then A dash you can say A into 2 capital T plus alpha, B into 2 capital T plus beta. This is how we prove it. That's how we prove it. Okay, do that proof. Okay. Now let's go to question number 41 and 42. 41 and 42. First read it. So we need to write parametric form coordinate. 41 and 42. First part, a line passing through 2, 3. The gradient minus 3. Then we have to write coordinate, any point on the coordinate, x bar, y bar, parametric form, y bar minus 3, x bar minus 2 equal minus 3, then y bar minus 3 over minus 3, x bar minus 2 over 1 equal t. You can put 3 minus 3 here or 3 here. Whatever it is, okay. Then if you write this way, then x bar equal t plus 2, y bar equal 3 minus 3t, minus 3t plus 3. Then corresponding point t plus 2, 3 minus 3t. Yeah, parametric form. Then there can be different parameters. There can be different parameters. Then we can write parametric coordinate according to that. So continue now. You think and do. Then that parametric form, we need gradient and a point on the line. No? We need gradient and a point on the line. By that we can write any point on the line. No? This is very important one because we have only one unknown. We have only one unknown. Take a little time. Okay, I think time's enough. Second part, gradient half, point 1, 2. Then y minus 2 over x minus 1 equal half. Then x minus 1 over 2, x minus 1 over 2, y minus 2 over 1 equal t. Then x equal 2t plus 1, y equal t plus 2. 2t plus 1, t plus 2. Then third one, 4x plus y minus 13. 4x minus y plus y minus 13. Here for this is somewhat very easy thing. So you consider x coordinate t. You consider x coordinate t, then 4t plus y minus 13, 0. No? Then you subject y coordinate, 13 minus 40. This is very simple way. If straight line given, you take one coordinate t, then write the other coordinate. So you take x coordinate t, then y will be 13 minus 40. And that is another simple technique. But if you write with gradient, sometimes this relation can be different. As according to parameter, the relation can be different. See? So if you take gradient minus 4, say y minus, you have to consider one point here. So if you get x0, we can find y coordinate 13, 0, 13. Likewise, we have to take one point. But better way, you better take x coordinate t, then by that you find y coordinate. Then y equal 13 minus 40. Then fourth one, so express the coordinate any point on the line through the point 3, 0, perpendicular line 3x plus 2y plus 5. Here 3x plus 2y, 3x plus 2y equal 5. 3x plus 2y equal 5. 3, 0. Here 3, 0 perpendicular to this line. Then here gradient minus 3 over 2 now. Then here gradient 2 over 3. Minus 3 over 2, 2 over 3. Here y minus 0 over x minus 3. That way you can write now. So that is general one. So anyway, to find parametric form, we need gradient and point. We need gradient and a point or a straight line. Then here x minus 3 over 3, y over 2 equal t. Then x equal 3t plus 3, y equal 2t. So you can put 2 here, then 2 over 3 times x minus 3 equal y minus 0. Whatever it is okay, but t can be different. Nah? T can be different. Okay, then 42 similar way, x plus y minus 1, then x plus y minus 1, you take x coordinate t, y coordinate 1 minus t. Then 2x plus y minus 4, 0, x coordinate t, y coordinate 4 minus 2t. Y coordinate 4 minus 2t. Then x plus 3y minus 5, 0, x coordinate t, y coordinate 5 plus t divided by 5 minus t divided by 3. so on we can write. This is parametric form. So if the line given, you take one point t, x coordinate t, then find y coordinate. Now we have done completely point straight line relations. Then we have to discuss only two point and straight line relations. Write down topic. 2 point and straight line relations. Relation. 2 point and straight line relation. 2 point and straight line relation. Okay. See now, we have only one theorem. So that is about point, position. That is about position. Okay, very simple theorem. Application is very simple. See now, let ax plus by plus c equals 0 and x1, y1, x2, y2 point are given straight line and 2 points. Okay, so this is very simple. Now we have to check. We have two cases. Here line ax plus by plus c. Then 2 point on lies on same side. x1, y1, x2, y2. Then here second case. Case 1, same side. Here ax plus by plus c equals 0. Here x1, y1. Here x2, y2. Now here opposite sides. Case 2. Two-point lies opposite side. Two different cases. Then the theory is simple. You substitute each point to this part. ax1, by1, c, ax2, by2 plus c. Then multiply them. So when they are same side, then here this will be positive. This product will be positive. Later we will prove that. When they are opposite side, ax1, by1 plus c, ax2, by2 plus c. When they are opposite side, this become negative. Then very simple application. Okay, we put this note first. I have given space, you can write that in the tutorial. Okay, first write it, later we will see application. Okay, now you see example. Now you see example. Consider 2x plus y minus 1 0 with 1 comma 1 2 comma minus 2. So you take this part and substitute point 2 into 1 plus 1 minus 1 and substitute again 2 into 2 minus 2 minus 1. Now see here 2 times here 4 1. Here we get positive value, no? If it is positive, we say they are lies on same side. For positive, same side. For negative, opposite side. We will prove it later. Then therefore 2 points lies same side to the line. To the line. Okay, complete. We have only one simple theory. Complete soon. Then you can do question number 42, page number 9, question number 42. Do it soon, huh? 42. I think time's enough. 42 first one, 5 into 2, 7 into 1, minus 4, 5 into minus 3, 7 into minus 1, minus 4. Now need to simplify. Here this is negative, and here again negative. Then it is completely positive. Then same side. X plus 3y minus 2, minus 2, 3 into minus 3, minus 2. Then minus 2, 3 into 7, minus 2. See, negative, 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 positive, negative. Opposite side. Third, 2 into minus 1, 0, minus 4, 2 into 5, plus 3 minus 4. Here minus, 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 here plus, negative. The negative means opposite sides. 4, 4 into 0, 3 into minus 1, plus 1, 4 into 3, 3 into minus 1, plus 1. Here negative, and here positive, negative. Opposite sides. Opposite side. That is very simple theorem. Okay. Now let's see that proof. Let's see that proof. See this proof. Now you consider the line ax plus by plus c equals 0. Here p x1 y1, q x2 y2. I'm going to check the position. I'm going to check the position. See my method. Huh? See my method. I'll take this point R. Now let PR is to RQ. K is to 1. PR to RQ, here you say K is to 1. You consider K is to 1. If K positive, then 2 points lies opposite side. No? If K negative, here this comes to the other side. If K negative, we say 2 points same side. That's the condition. Identify, we have taken here K is to 1 ratio. If K positive, then we say they are opposite sides. If K negative, we say they are same side. Okay, anyway now, here 1 to K ratio internal division, you write R coordinate now. K to 1 internal division, you write R coordinate. K times x2, 1 times x1 over K plus 1. Internal division theorem, coordinate geometry. K times y2, 1 times y1, K plus 1. Hey, see? This is point R. Then R on the line, no? R on the line. So previous theory, previous one, point straight line relation I gave you. If point on the line, we can substitute it, no? If point on the line, we can substitute it. Therefore, R is on the line. Then you substitute this point to the line. X mean kx2 plus x1 over k plus 1. Y mean ky2 plus y1 over k plus 1 plus c0. Okay, now you find k value. Okay, start now. Start. You start. I'll find k. A k x2, a x1, b k y2, b y1, c k plus c. Then take k terms together. A x2, b y2, c, a x1, b y1 plus c 0. Then k minus a x1, b y1 c, a x2, b y2 plus c. First you take up to this, then we can analyze it. Okay, now come to here. Now we got k value now. K value is this. Now I'll do this say. Then I'll do this say minus, I'll multiply by same denominator here. A x1, b y1 plus c, a x2 plus b y2 plus c. Now denominator we get a x2 plus b y2 plus c squared, no? C square. Then we know here denominator positive and here negative. Then if this part negative, negative times negative positive or positive, k become positive. No? If this part negative, k become positive. K positive mean 2 point lies opposite side. No? If this part positive, then positive times negative, negative over positive, negative. Then negative mean k become, points become same side. No? Okay, now we'll say therefore ax1 by1 plus c ax2 by2 plus c greater than 0, corresponding to that k value use a negative. Therefore points opposite same side. ax1 by1 c ax2 by2 plus c less than 0, that means k positive. Then therefore points same side, opposite side, lights opposite side. Okay, complete that proof. Okay. Now, next case about two straight line relations. Then there are only few theorems with that. Then we can complete the lesson. Write down next topic, two straight line relations. Two straight line relations. We have only few theorems, very few theorems. Two straight line relations. Okay, PO paper question number 8 will be directly straight line. PO paper question number 16 will be straight line, circle, mixed question. So that is single question. Then we need straight line both and circle. Okay. Okay, see now. So first one, position. Position. So here one is like this. Say gradient m1, gradient m2. Then here another thing. Gradient m1, gradient m2. Here parallel, gradient same. m1 equal m2. We say parallel. Then here inclined. m1 not equal m2. They are not same. Then here perpendicular. Say gradient m1, gradient m2. here m1 times m2 equal minus 1 perpendicular. This is first case. So we have to think only about their gradients. That's it. You think only about their gradients, extract gradient and analyze it. If gradient same, parallel. If gradient different, they are inclined. If gradient product minus 1, they are perpendicular. This is first theorem. Okay, put it. Okay. Now that is very simple. No? Now especially we have two cases. No? So one is parallel, the other one is inclined. No? Inclined case we have special one perpendicular. No? Okay. If two lines are inclined, then we have another few theorems. When two lines are parallel, we have only one theorem. See that? When lines are parallel, right? Lines are parallel. Here say ax plus by plus c equals 0, no? So identify my case, this case. Ax plus by plus c equals 0. So gradient represented by a and b coefficients, no? A and b represent their gradient. When you subject y, minus a or b will be gradient, no? Then now these two lines parallel mean their gradient same. Their gradient same mean these two terms will be same, no? Then you write here, when two lines are parallel, then here this line ax plus by plus, only constant will be different. Then you have to identify. When x and y coefficients are same, they are parallel. So when they are parallel, we have one theorem that is about perpendicular distance between them or shortest distance between them. When two lines are parallel, we have only one theorem that is about shortest distance between them. Shortest distance between two parallel lines. Now here see, the theorem is very simple. Here we have constant term c and d, no? Then we say L c minus d modulus over a squared plus b square root. You remember this one directly. C minus d over a square plus b square root. We can prove that one. Then see proof. Take this point alpha comma beta. Then alpha comma beta, from that alpha comma beta we can sketch perpendicular. So previous theorem we can obtain that. No? We know previous theorem. Then distance from perpendicular distance from this point. Then A alpha plus B beta plus C modulus over A square plus B square root. Previous theorem we got that, no? And further alpha beta on this line, no? Alpha beta on this line. On Ax plus by plus d equals 0. Then you can substitute it. A alpha plus B beta plus d 0. Then say A alpha plus B beta minus d. A alpha plus B beta minus d. Instead of this you put minus d. That's how we prove. Okay? You do that proof. First write this theorem and highlight it. Thereafter do that proof. Okay. Now when two lines are parallel, we have only one theorem. So when two lines are inclined, we have another few theorems. Let's see. Now here, ax plus by plus c0, a1, b1, c1. Ax by plus c0, a2, b2, c2. Here, gradient minus a1 over b1. Here, gradient minus a2 over b2. Therefore, a1 over b1 not equal a2 over b2. No, this is one thing. This is one thing. When they are inclined, their gradient not same, no? When they are inclined, they intercept, no? When they are inclined, surely they will intercept. That interception point here, this interception point we can find by solving this equation. By solving this equation. Okay. Interception point can be obtained by solving equations. By solving equations. Now you take gradient m1 and take gradient m2. Here these are gradients. Now we have acute angle and obtuse angle. Here acute angle. Here obtuse angle. Then this acute angle we can say acute angle. Tan inverse. Here gradient m1, m2, no? m1 minus m2 over 1 plus m1, m2. Okay? Tan inverse m1 minus m2 over 1 plus m1, m2. m1, m2. This is acute angle. This is another theorem. Now here we have two theorems. One is interception point. That interception point we can find solving the equation. Very simple. Then the angle between 2 points, 2 lines, we can say tan inverse m1 minus m2 over 1 plus m1, m2 modulus. Then here acute angle. Then obtuse angle means pi minus theta, no? Here acute angle, then obtuse angle. Pi minus theta, no? Then pi minus tan inverse m1 minus m2 over 1 plus m1, m2. Okay, write it. Okay, now see the proof. So while you are writing, see the proof. Here x-axis, here these are two lines, let's say gradient m1, gradient m2. Then take this angle alpha, here beta, here theta. Tan alpha m1, tan beta m2. Then theta equal alpha minus beta, no? Then tan theta, tan alpha minus beta. Then tan theta, acute angle, you put modulus. For obtuse angle, we get negative values now. So when we extract only positive value, we say that is acute angle. When we put modulus, we say that is acute angle. Then here tan alpha minus tan beta over 1 plus tan alpha tan beta mod. Tan alpha m1, tan beta m2. Then you say now tan theta acute angle equal m1 minus m2 modulus of m1 plus m2. Then theta acute tan inverse m1 minus m2 over 1 plus m1 m2. That's how we prove. Do that proof. You apply these theorems directly. Yeah? These are the proof. Okay, do it. Okay. Now let's do 2-3 questions. Okay, you try these questions. Huh? Okay, do these questions soon. හරි බලන්න ඔයාලා දිගට හදාගෙන යන්න මම මේක ඩිස්කෂන් එකකට එන්න. Okay, question number 43. Question number 43, find acute angle. First part, gradient m1 minus 3 m2 minus half. Then theta tan inverse modulus minus 3 minus half 1 plus minus 3 times minus half. Yeah, acute angle. Tan inverse 1. Pi divided by 4, no? Pi divided by 4. Then second one, m1 gradient root 3, m2 gradient 1 over root 3. m1 gradient root 3, m2 gradient 1 over root 3. Then theta tan inverse m1 minus m2 1 plus m1 m2 modulus. Then tan inverse 2 1 over root 3. Pi divided by 6. Pi divided by 6. Check your answers. Third one, m1 2 minus root 3, m2 2 plus root 3. Then theta tan inverse 2 minus root 3 minus 2 plus root 3 1 plus 2 minus root 3 2 plus root 3 modulus tan inverse 2 root 3 minus 2 root 3 here 1 4 minus 3 mod 1 4 5 3 2 root 3 pi divided by 3 for m1 minus b over a m2 minus a over b. Then theta tan inverse modulus minus b over a minus a over b. 1 plus minus b over a minus A over B. Okay, simplify. Then here tan inverse A square minus B squared over A square minus B squared over 2AB. 2AB. Okay. 43. Check your answers. Take time. Okay. Then question number 20. Questions numbers පොඩ්ඩක් miss එහෙම වෙලානේ. Question number order එක පොඩ්ඩක් මාරලා තියෙනවා ටියුට් එක ගණන් ගන්න බෑ. Question number එකට යමු. Question number 20. Show that the following pair of lines are parallel. First one gradient m1 minus 1, m2 gradient minus 2 over minus 2, minus 2 over plus 2, minus 1. m1 equal m2, therefore parallel. Second one, m1 minus 5 over 3, m2 minus 5 over 3. m1 equal m2, parallel. Third one, m1 2 over 4, m2 1 over 2, here half. Then m1 equal m2, parallel. m1 1/3, m2 2/3, 2 over 6, 1/3. m1 equal m2, parallel. 20. Then question number 32. We have to select perpendicular pairs. Then first one, m1 gradient 2/3, m2 gradient minus 3 over 2. Then perpendicular, na? Perpendicular. Then here m minus 1 over m. They are perpendicular, na? m1 times m2 2/3 minus 3 over 2 minus 1, perpendicular. Second one, m1 2, m2 1 over 2. m1 times m2, 2 times 1 over 2. Here 1, they are not perpendicular, na? 1, not perpendicular. Third, m1 3/4, m2 minus 4/3. Then m1 times m2, 3/4 minus 4/3 minus 1, perpendicular. 4, m1 5/3, m2 5/3, not perpendicular. Then fifth, m1 minus 2/3, m2 3 over 2. Then m1 times m2 minus 1, no? Minus 1, then perpendicular. That is question number 32. Okay. Then question number 24. Question number 24. We have to find shortest distance. So we have directly theory now. Then first you convert into ax plus by plus c equals 0 format. Then 3x plus 4y minus 12 0. The other one 3x plus 4y minus 2 0. Then perpendicular distance c minus d. Modulus over a square plus b square. Root. Here 2 units. Here 10 or 10 divided by 5. Second one 5x minus 12y plus 2 0. Then 5x minus 12y plus 7 0. Then L c minus d 7 minus 2 mod over 5 square plus 7 square root. 7 minus 2 5 over here 12 no? 13 units. Third 3x minus 4y minus 8 0. The other one 6x minus 8y plus 5 0. This is very important. We have to convert same order. Then here 3x 4y, here 6x 8y. Then you divide by 2 this. Then 3x minus 4y plus 5 over 2. Then here c minus d. C mean minus 8, d mean minus 5 over 2. C minus d modulus over a square plus b square. 3 square plus 4 square root. Likewise you have to convert. Here 16, 21. 21 over 10 units. 16, 21 minus minus cancel. Then 2 goes downstairs. 21 over 10. That is third one. Then fourth one 3x plus 4y minus 5 0. 6x plus 8y minus 45 0. Then here you convert into this format. 3x plus 4y you have divide by 2 no? 45 over 2. Now this is c, this is d. Then length c minus d modulus over a square plus b square. Then 10 35. 2 times 5, 7 over 2. That is question number 24. Okay. Then 23. 23. Before that you see this one. So here gradient m1, here gradient m2. Then angle, acute angle, we write tan inverse modulus m1 minus m2 over 1 plus m1 m2 module. Here we have two cases, m1 equal m2 theta 0 degree. Therefore lines are parallel. Then the important thing is a line parallel to ax plus by plus c equals 0. See this one? This is very important thing. Line parallel to ax plus by plus c equals 0 is ax plus by plus d equals 0. You can change only constant. You can change only constant. Then lines will be parallel. Then another thing, m1, m2, m1, m2. When denominator part 0, 1 plus m1, m2 equals 0, then denominator 0, 1 over 0, infinity, no? Then theta become 90, or perpendicular. Right? Therefore, you say, therefore, lines are perpendicular. Lines are perpendicular. Here, the important thing is a line perpendicular to ax plus by plus c equals 0 is, check this one. Now, when lines are perpendicular, gradient, reciprocal, and we have to reverse the sign. No? Then reciprocal means we have to interchange a and b. Interchange a and b, we have to reverse one sign. Then you say, a, here ax you put bx, and here ay. You change one sign here or here, and change constant. This is line perpendicular to that. You have to interchange ab and reverse one sign, and change constant. Or we can put minus here, minus bx plus ay plus e equals 0. Anyway, we have to change constant always. And we have to interchange x and y coefficient with the sign. Okay? This is how we write perpendicular line and parallel line. Okay. You better to put this note. While you are doing, put this note. Okay. Then question number 23. Question number 23. Line parallel to 7x minus 5y plus 3 equals 0. Here line, then line parallel to that passing through the origin 0, 0. Then here gradient 7 over 5. Then here also gradient 7 over 5. Then we know gradient and intercept, no? Gradient and point. Then y minus 0, x minus 0 equals 7 over 5. Then 7x minus 5y 0. Second one, straight line parallel to 2x plus 3y plus 5 0. Passing through the point 1 comma 5. Then here gradient minus 2/3. Then here also gradient minus 2/3. No? Then write y minus 5 over x minus 1 minus 2/3. Then 3y minus 15 minus 2x plus 2. 2x plus 3y minus 17, 0. Then third one, line parallel 3x minus y equals 6. Then here gradient 3. Then 3 equal y minus 2 x minus minus 1. Then here the line 3x plus 3 y minus 2 3x minus y plus 5 0 4. Then gradient minus 3/4 y minus minus 7 x minus 1 minus 3x 18 4y 28. 3x plus 4y plus 10 0 plus 10 0 23. Okay, then 34. No, 33. Line perpendicular to 3x minus 2y equal 1. Line perpendicular to and this and passing through 0 0, no? Then here gradient m 3 over 2. Then perpendicular line gradient minus 2 over 3 passing through the origin. Then y minus 0 x minus 0 passing through 0 0. 2x plus 3y equals 0. Second one, 4x plus 3y plus 1 0. Gradient minus 4/3. Then line perpendicular to that 3/4. Then take reciprocal and reverse sign. Passing through minus 1 3. 3x plus 3 4y minus 12. 3x minus 4y minus 15 0. Second one. In third one, straight line through the midpoint of the line joining 2.2, 7, 4, 1. Then 2, 7 minus 4, 1. Then find midpoint. Add and divide by 2. 2 minus 4 divided by 2, 7 plus 1. divide by 2. Then midpoint here minus 1, 3, minus 1, 4. Then line 5x minus 2y. No? And here 5x minus 2y equals 7 gradient 5 over 2. Then perpendicular line minus 2 over 5 gradient. Point is this. Point is this. Y minus 4, x minus minus 1. Minus 2x minus 2, 5y, 20. 2x plus 5y minus 18, 0. Minus 18, 0. Do up to that. Then fourth one, perpendicular bisector. 2 points are given. One, 1, 2, 3. Here take gradient m. 3 minus 1 over 2 minus 1, 2. Then perpendicular line gradient minus 1 over m, no? Then minus half. Then here perpendicular bisector. Then m, 2 plus 1 over 2, 3 over 2. 3 plus 1 over 2, 2. Then here the point and the gradient. Then line minus half equal y minus 2 over x minus 3 over 2. Minus half 2y minus 4, 2x minus 3. Simplify. Minus 2x plus 3, 4y minus 8. 2x plus 4y minus 11, 0. Complete. Question number 34. We have to find k value where the lines are perpendicular. When lines are perpendicular, gradient product minus 1, no? Then gradient 2 minus 2. Then next case k divided by 2 minus 1. Then k value 1. K over 5 minus k over 5 gradient, then 5 over 2 minus 1, then k value 2. Minus 3 over 2, k equal minus 1, k equal 2/3. For gradient k minus k equal minus 1. K divided by 4, no? Then k square equal 4. K equal, we have two possibility, plus or minus 2. That is 34. Then similar type question 22. the lines are parallel, then equal gradient minus half equal k. Lines are parallel, gradients are same, then equate gradients, then k equal minus half. Second one, minus 3 over 5 equal 3k over 10 minus 3k over 10. Simplify, k equal 2. Third one equal 3 over k minus 3 over k equal minus 3. Minus 2 over k minus 2k over 4. K squared equal 4 plus or minus 2. Plus or minus 2. Okay, you continue with these questions. Okay, do them. I'll give you small time. You start. Here, check this one all. You consider a1x, b1y, c1 equals 0, a2x, b2y, c2 equals 0. Then intersection point we can write directly. See this method, intersection point. Here I'm going to find x coordinate. You cross this x, then cross multiply coefficients only. b1 c2, b2 c1. Subtract. Then cross constant, do same thing. a1 b2 minus a2 b1. Here direct technique to solve simultaneous equation. So when you find in y, you do same thing. Cross this a1 c2 minus a2 c1. Denominator, cross this a1 b2 a2 b1. But you have to remember, when you are finding second unknown, put minus sign in front of that. This is shortcut method, direct method. You can take that one. That is about solving simultaneous equation. Cross x, multiply, cross multiply coefficient b1 c2 minus b2 c1. Cross constant, do same thing. a1 b2 minus a2 b1. Then when finding second unknown, cross this a1 c2 minus a2 c1 over cross constant a1 b2 minus a2 b1. Then second unknown, you have to put minus sign in front of that. Okay. Then 44. Page number 1144. There's another 44. Page number 11. Page number 1144. Show that the following straight lines are concurrent. Page number 11. Then 2x plus 3y plus 4, 0. X plus 4y plus 1, 0. Then find intersection point. Cross this 3 minus 16 over 8 minus 3. Cross y 2 minus 4, 8 minus 3. Minus 13 over 5. 2 over 5. Then third line, x minus 6y plus 5. No? Then substitute here. You get here line u, you substitute this point, minus 13 over 5, 2 over 5. See what will happen. Minus 13 over 5, 6 times 2 over 5 plus 5. Here minus 5 plus 5, 0. Then that is satisfied, no? Therefore you say, therefore concurrent. They meet at same point. Then when you solve in two equation, you better to get that direct method. Take time. Okay, then second one, similar type question. 5x minus 2y minus 16, 0, x plus 2y plus minus 1, 0. So here simultaneous equation we can easily simplify. 1 plus 2, 6x minus 17. X equals 17 over 6. Then by 2, 17 over 6, 2y minus 1, 0, 2y, 1 minus 17 over 6, minus 11 over 12. Then the line here, 3x minus 4y minus 11, 0. Take here u, then you substitute that coordinate. Here this notation, we can put square bracket and the coordinate within 17 over 6 minus 11 over 12. 3, 17 over 6, 4, minus 11 over 6, minus 11 over 12. 7 over 2, 11 over 3, 11. Zero. Therefore concurrent. Satisfied now? Then that is concurrent. Take your time. Take your time. Here 17 over 6. Yeah, not concurrent. Concurrent, no? That's not concurrent. Then question number 45, following lines are concurrent, find the value of k. So you solve any two equation, better to get first and third. X plus 3y equals 6, 5x plus 6y equal 13. First solve these two. 1 into 2 minus 2. 2x, 3y, 5x, 6y, 6 into 2 minus 13. Minus 3x minus 1, x equal 1/3. Then substitute to 1. 1/3, 3y equals 6. 3y, 6 minus 1/3. 17 over 9. Therefore, corresponding point 1 over 3, 17 over 9. Then concurrent, then third line, kx minus 9y plus 40. So you can substitute there, no? Substitute. K times 1/3, 9 times 17 over 9 plus 40. Then k value 17, 13, 33, 39, no? 17, 13, 39, k value 39. Solve two equation and substitute the other equation. No? You better to select completely non equations. Continue. Second part. Two x minus 3y plus 12 0, 4x plus 5y plus 2 0. Solve simultaneous equations. 1 into 5 minus 2 into 3. 2x minus 3y plus 12. 4x plus 5y plus 2, 0. Minus 2x, 48. 54. X 27, no? Okay, then find y. 2 times 27 plus 12 divide by 3. 22. Then coordinate 27, 22. Check simplification. Then substitute 2x plus ky plus 8 0. X equal 27, y equal 22, 8 0. Simplify. 27 plus 4, 31 over 11 minus 31 over 11. Here there's simplification error, plus, then only we cancel 15, 10, 12, 22, 66. Then x equal 3 minus, then y 2 into minus 3 plus 12 over 3, 2. Then minus 3 comma 2 substitute. K equal 1. K equal minus 1. K equal minus 1. Okay. Now you come to this. See this one. Check this one all. Now angle bisectors. Angle bisectors. You consider here there are two lines, they intercept. Here say a1x, b1y, c1 equals 0, and here a2x, b2y, c2 0. Now here this line we call acute angle bisector, and here this line we call obtuse angle bisector. Acute angle bisector. Here we call obtuse angle bisector. So here we have direct theorem to find that. So that is, so when you consider some point here, then perpendicular distances are same, no? Say x bar, y bar, perpendicular distances are same. Then from this point you find perpendicular distance, and from this point you find perpendicular distance. We have theory for that. Then a1 x bar, b1 y bar, c1 modulus over a1 square b1 square root equal to a2 x bar, b2 y bar, c2 modulus over a2 square plus b2 square root. Perpendicular bisectors. Now let x bar x, y bar y. Then a1x, b1y, c1 over a1 square, b1 square root, put plus or minus a2x, b2y, c2, a2 square, b2 square root. Here these are angle bisector equations. Angle bisector equations. Equations of angle bisectors. angle bisectors. Okay, so one is acute angle bisector, the other one is obtuse angle bisector. So we need to know how to classify them properly. But anyway, these two represent angle bisectors. First you put this note, you can apply them directly. Put that one, angle bisectors. You better write somewhere. There are two angle bisectors between two lines. There are two angle bisectors between two lines. There are two angle bisectors between two lines. First one, acute angle bisector, second one obtuse angle bisector. First one acute angle bisector, second one obtuse angle bisector. Okay, then you sketch and write. Later we will see how to apply directly and how to classify them at once. Okay, do it. Okay. Page number 16, question number 65. Page number 16, question number 65. Okay, question number 65. We can apply directly. Here two lines, 3x plus 4y minus 12, 0. 4x plus 3y minus 23, 0. Then you do this, say 3x plus 4y minus 12 over 3 squared plus 4 square root, and plus or minus 4x plus 3y minus 23 or 4 squared plus 3 square root. Here these are angle bisectors. Cancel. Take plus sign. 3x plus 4y minus 12. 4x plus 3y minus 23. Then here x minus y minus 11, 0. Then take negative value. 3x plus 4y minus 12 minus 4x minus 3y plus 23. Now take positive and negative separately. Then 7x plus 7y and 35, 0. We can, it is divisible by 7. X plus y minus 5, 0. Here the bisectors. Very simple theory. Do it. Complete that question. Now with star mark write down selection of acute angle bisector, obtuse angle bisector. Okay, write this way. To select, write down to select angle bisectors. To select angle bisectors, use the following working rule. Use the following working rule. Use the following working rule. Number 1. Select one of the bisector. Select one of the bisector and take it gradient m1. Select one of the bisector and take it gradient m1. Number 2, select one of the line given. Select one of the line given and take its gradient m2. And take it gradient m2. take it gradient m2 and check the value m1 minus m2 over 1 plus m1 m2 modulus, and check the value m1 minus m2 over 1 plus m1 m2 modulus. Here we get two possibilities here. We get two possibilities, greater than 1 or less than 1. Then if it is less than 1, selected bisector is acute angle bisector. For negative 1, selected bisector is acute angle bisector. Greater than 1, selected bisector is obtuse angle bisector. Obtuse angle bisector. Okay. The procedure is simple. No? So if that value less than 1, we call selected bisector is acute angle bisector, otherwise obtuse angle bisector. Here we use one of bisector, no? One of the bisector, here one, here another one. If you select this one, and thereafter we select one line, this one or this one. So if this one acute angle, then one angle will be less than 45. No? That's why we consider tan 45. Tan 45 1, then less than tan 45 means less than 1. So check with this. You select one bisector. I'll take this. Take its gradient m1. It is 1. Gradient 1. Select one of the line. I'll take this. Take gradient m2 minus 3/4. Then you check the value here. Check the value. Okay. Now see m1 minus m2 1 plus m1 m2 modulus m1 1 m2 minus 3/4 1 plus m1 1 m2 minus 3/4. Now see here 7, we get 7. Then greater than 1, then selected bisector. Selected bisector is obtuse angle bisector. This one obtuse angle. Therefore, x minus y minus 11 equals 0 is obtuse angle bisector. Obtuse angle bisector. Okay, very simple technique. But need to remember, you select one of the bisectors. Thereafter take gradient m1. Then you select any line. Then take its gradient m2 and check the value m1 minus m2 or 1 plus m1 m2. Then if that value greater than 1, say it is obtuse angle bisector. If it is less than 1, say it is acute angle bisector. Okay. Do that example. Do that one. Okay, let's do another question with me. Question number 66, second one. Question number 66, second part. 2x minus y minus 4, x minus 2y plus 10, plus or minus 2 square plus 1 square root, 1 squared plus 2 square root. 2x minus y minus 4 plus or minus x minus 2y plus 10. Then get plus answer. 2x minus y minus 4, x minus 2y plus 10. X plus y minus 14, 0. Here 1 bisector. 2x minus y minus 4 minus x plus 2y minus 10. Then 3x minus 3y plus 6, 0. X minus y plus 2, 0. Here another bisector. Then you select one bisector. I'll take this. Find its gradient 1. Then select one of the line. I'll select this one. 2x minus y minus 4. Gradient m2, 2. Then check the value m1 minus m2 over 1 plus m1 m2 mod. Then m1 1, m2 2, 2 times 1 times 2. 1/3. We get 1/3 less than 1. Therefore, selected one is this. X minus y plus 2 equals 0 is acute angle bisector. Acute angle bisector. No? Okay. Then last theory. Last one is it's about family of lines. You consider here 2 lines are given. Say here u1, a1x, b1y, c1 equals 0. Here say u2, a2x, b2y, c2 equals 0. Then here intersection point. Then there can be many different lines can be drawn passing through that intersection point. No? Likewise, there are infinite lines we can sketch. Then those lines are called family of lines. 1, 2, 3, 4. Likewise, there are many lines we can sketch. Then all represent these lines. Then family of lines. Family of lines passing through the intersection point. point of given two lines, we can write that one u1 plus lambda u2 equals 0. Here this is our format. u1 mean a1x b1y c1 plus lambda times a2x b2y plus c2 equals 0. We call lambda variable parameter. So as lambda varies, this line can be rotated, but that point is fixed. Here we call family of lines. And another way we say this one, a variable line passing through a fixed point. We call a variable line passing through a fixed point. Okay, that is another special thing. So here this one, other word we say a variable line passing through a fixed point. We call family of lines. Okay, put that note. Here there's one important thing. u1 plus lambda u2 equals 0. Lambda u1 plus u2 equals 0. Lambda can be, we can put with u1 or u2, whatever it is, okay. Or you can write here lambda 1 u1, lambda 2 u2 0. Likewise, you can put two parameters as well, no issue. So if you put lambda 1, when you divide by lambda 1, then u1 lambda 2 over lambda 1, it's look like this, na? Then all are similar expressions. Page number 8, question number 38. First read it. Page number 8, question number 38. Page number 8, question number 38. So we can apply that. Straight line joining the point of intersection of line 3x plus 4y equal to L, 2y equal x plus 5 to the point 1, 1. See, two lines given, better take general form. 3x plus 4y minus 12, 0. The other one, x minus 2y plus 5, 0. Then passing through this point with 1, 1. Then you write here these two given point, no? Then write just family of lines. Family of lines. Here x minus 2y plus 5 plus lambda times 3x plus 4y minus 12. This represent many lines. Here this represent many lines. As x varies, we can say there are many lines there. Now, specific one passing through 1, no? Specific one passing through 1, 1. Therefore, passing through 1, 1, then you substitute it. Then you substitute 1, 1. 1 minus 2 times 1 plus 5. Lambda times 3 times 1 plus 4 times 1 minus 12. 0. Simplify. Here 4. Lambda times 3, 7, 12, 5. Minus 5. Then lambda value 4 divided by 5. Lambda value 4 divided by 5. No? Then here general one, here specific one. Then this lambda value you put in here and rewrite the equation, corresponding equation. No? Therefore, required equation again take this and put that lambda x minus 2y plus 5, 4 divided by 5, 3x plus 4y minus 12, 0. 5, 17x minus 10, 16, 6y, 25, 25, 35, 45, 23, 0. This will be the line. That's how we use family of lines. Okay, do that example. Okay, now we have done every theorems under straight lines. You do all the remaining questions, but sometimes I may need to discuss few of them. But anyway, you try to do all the straight line questions up to page number 16. Up to page number 16, okay? Okay, that's enough for today.